Howdy folks, welcome back. This is the master cylinder for the front brake on the VFR 750, and what we have here is one of these sight glasses. Typical issue, these things become petrified. I think the plastic dates back to the Jurassic period. So this is cracked and it's leaking, so it needs to be replaced, plus you can't see through it anyway. So I looked online to see about the procedure because I've actually never done this, and I found a video. I'll link to it if I can remember to do that in the description. But gentleman, took it out and replaced it with something that he had custom made. So in other words, somebody machined him or otherwise made a piece of plexiglass to shove in there, and he uses a small syringe with some silicone, RTV silicone, and it's a press fit, so it's a pretty tight fit, and then the silicone seals it in and also is an adhesive. So you know what, I'm going to try that. I'm going to show you how I'm going to try to fix this, and of course, if you're seeing this video, it worked. If you're not seeing the video, then it didn't work, and I'm just going to order some, this is 18 millimeter, this diameter here, some 18 millimeter sight glasses, and I'll just fix it the correct way, I guess you might want to call it. The first thing we need to do is get this out, and what he said in his video is he starts reaching through from the backside in between those little slots or slits in that little piece of metal, and what that metal does essentially is kind of a damper, so the level stays pretty even when this thing is vibrating around. Or a baffle, little damper, a baffle. So it just allows a certain amount of fluid in there, and it doesn't just slosh around where you can see it. We're going to try to reach in through here and try to tap that out, and or otherwise, get through it. What's going to end up happening is the plastic's going to break, and once we have a penetration from the front, we can just start prying it out this way. I could also do that as well. I could just put a drill bit in here, and I might end up doing that and just poke through and then start levering it out from the front. But I'm going to go ahead and try to push it through from the back first. Put a little bit of heat from a heat gun on it and see what we can do. Then once we get it out, we'll take a look at it, measure it up real closely, and I'll show you my idea. I think might be able to make something in-house to fix this with. I'm in the soft jaws here. I don't really know how much you're going to actually see of it, but best I can do right now to try to reach in there and push it out. I got to get the heat gun out first though and give it a heating, but I wanted to show you the setup at least. Yeah, getting that piece of metal a little bit. I've already broken through, so let's just pull it from the outside. I don't want to damage that metal any more than I already have. Ooh, that's warm. Yeah, see? I knew that would happen. That's okay. Well, that came out pretty good. Yeah, there we go. Yeah, this wasn't long for this world. Yeah, okay, let's see what we got. Not sure if this piece of metal comes out or what. I think I'm just going to leave it in because we're going to be dealing with this area right here. You have a shoulder and this bore, which luckily isn't all corroded. And that's where the little window sticks in. So this must be something that's pressed in first. We're not going to have to worry about that. As long as the little window seals off, then I think we'll be good. Alright, so let me clean out this mess here best I can off camera. We'll dig this out a little bit. I'll show you what I'm going to do to try to fix it. I kind of see how this goes now. This entire thing is like an assembly. It comes attached apparently to that metal piece. Because you can see this outer ring here. This one right there, which is, it's entire, the whole thing is just pressed in. So what we're going to do is we're going to try to make a piece that goes inside there and just replace that. And all I'm doing is cleaning up the junk that's inside there right now. Try to make it as clean as possible. For two reasons. Number one, I don't want it to look like shit if we can do it. Number two, I don't want any of these little particles going into the master cylinder and screwing up the tiny little holes in it. Just wanted to point that out though. This is an entire thing that gets pressed in because there's the edge of it right there. But that ain't the leaking part. The leaking part's the glass, so to speak. So that's what we're going to work on. We'll see what we can do. Probably should tighten the chuck. Okay, so here's the setup. This is a trick I picked up from Cutting Edge Engineering's YouTube channel one time. I don't know how many videos ago it was, it doesn't matter. Where if you have a situation where you have a piece that you need to turn the OD of, but you can't clamp as far as the jaws of your chuck go on the OD, nor do you have an ID. Like we can, if this was a hole in the middle of it, we can make an arbor and then tighten it up with a nut and a bolt and then turn the OD, but obviously we can't put a hole in the middle of it. It'll defeat the whole purpose. So what we do is, first piece you saw me make was this. That's cut with that same, I think it's 60-degree inclusive angle as far as the live center goes. And so this is pressed in, when it's pressed up by the tailstock, that is, it's nice and square inside here. And I faced the end of that so it's nice and square. And then made this piece where that relief down in there is a little bit smaller than my maximum OD of the piece that I'm going to turn, essentially, in the lathe, this piece of plastic that you saw me cut on the Grizzly drill press. Let's take a look at our dimensions here. This is an 18 millimeter, I'm pretty sure, but that would be the size of the bore that this assembly goes into. So we're going to be doing this section here, the inside part of it, essentially replacing the glass. And that is about 670 thou. So we're going to cut that just above that and then bring it in with some sandpaper, and then we're going to test fit it. The only problem with this is it'd be almost impossible to duplicate the setup. Obviously, if I relieve it from here, I'd have to indicate it back in, and that'd be a real prick. So we're going to bring this down and essentially just use, measurements here to determine whether or not we're going to be able to put it in. I mean, I could do that if I needed to, but that would be a hell of a difficult thing to do with this because there's no tapping it around or anything. It is what it is once you line it up. So we're going to give it a shot and see what we can come up with. I'll remeasure it to make sure. I can't really get an ID mic in there, so it's going to have to be my Starrett 120s. Then we'll take it down. I sharpened the tool bit. High-speed steel. The whole problem with cutting plastic is heat. The shit starts to melt, especially if the tool is dull. I don't want to be spraying any water in here, so we're going to try that. We'll do a skim cut and see how it works. First, we'll cut off this edge here, kind of that remnant of the drilling. And really, what I did was on that Grizzly drill press, I backed off the center drill of a hole saw. That way it's essentially a boring saw at that point. And I can do that because I'm in a drill press. You couldn't do that freehand. Could have used a mill too, but the drill press was just easier to set up for that, I'd have to take the vise off, and that's a prick to tram back in. So anyway, I'm rambling. Let's get to going on this. Alright, not quite cleaned up yet. That's another problem with this. It gets all sorts of stringy chips in here and it makes a big mess. Okay, but not a bad finish. You can finish these off with a little sandpaper. This is basically windshield material. Lexan, plexiglass, whatever you want to call it. And this stuff cuts really well. If you want to cut a windshield down, you can use a scroll saw, make as straight a cut as possible, and then just bring it in with the various grits of sandpaper, and it'll look factory. I've done it many times. Well, not many. I've done it numerous times before. 1.185. So we got some room to go. So I'm going to go ahead and get this cut down. I'm going to have to take light cuts. I'm not going to film all that because, you know, that'd take a while. I want to take a chance of spinning in here. As you can see, if I didn't explain it well enough before, your tailstock is putting pressure up against this piece, which pushes it up against the actual work, and then the work presses up against this piece that I made, and of course this dead ends in the jaws, in the chuck rather. As long as you got a really good pressure on it, which I do, and then you lock your tailstock, shouldn't go anywhere. So anyway, I'm going to cut it down and we'll come back when we're getting close. We're 8 thousandths out from being exactly the same size as the hole. I think that's what I'm going to shoot for. I mean, this is plastic. It should be able to press in like that. I'm still deciding that, but I guess we'll start there at least. And then, yeah, I'll have to figure that out. Really no way to tell. Like I said, as soon as I break this down, there's going to be no way to get it back in accurately without indicating it in, and that is really going to be a pain. So, yeah, we're at 678 now, so we want to be at 670 thou, 0.670. 74.5. That's where we're at right now. Half thou below, maybe not quite a half thou, so pretty much right on, good enough for this purposes. Now, here's the other dilemma we have here. And I know this is getting complicated, but, you know, hell, why not give it a shot, right? This is a little too thick for the depth of this right there. You see the step? That's 1/8 of an inch. And this material is, well, it's bigger than that. I can't exactly remember. Let's measure it up here. Yeah, it's about 160, 155. It's about that wide. So it's 25, about 30 thou wide. So what I'd like to do is, I'm going to turn a compound so I can do like a, I don't know, 10 degree, 20 degree chamfer. Then I'm going to chamfer it in this way. Let me back you out and show you. We're going to chamfer it in this way because this is going to be the outside of it. And we'll bring that in so the narrow part is at depth. And then it'll have a little bevel, which is kind of what the original looks like. It's a little bit, you know, has a round part to it. So I think that'll be an interesting feature. Then the last thing we need to do is come back here. We'll just use the back side of this tool, and we'll put a little bevel on it as well, which will help us get it started into the hole, assuming that the number is good as far as the size. 30 degrees looks better, so this is 1/8 from the back side, so we're just going to chamfer that back just a little bit until we get to that 1/8 there, see? Doesn't have to be all that precision, or precise rather, but you know. That looks about right. Now I'll just readjust here. Actually, I don't even need to readjust. We're at a perfect angle right now the way this compound is set. Just come in here. We'll even use the compound for it. And just bring this in and then touch off. We'll touch off on the aluminum just a little bit. And then just break that back. Whoops, just break that back edge. Sure, my cross light ain't hidden. That would be bad. Alright folks, I double triple checked. It's right where I think it needs to be. This is a guess, never did it before. So we'll go ahead and break the setup here. And again, this is how that works. See, it's got a, I think that's a 60 degree inclusive angle for the live center. You got to use a live center for this. There's no way around it. You got to have a live center that'll turn when you put that kind of force on it. And then again, that butted up against the work. And then the work butts up against that. And speaking of work, that's the work. Right there. I'm not sure if it's going to go in, folks. I mean, I don't know. But we're going to give it a shot here. Clean it up and make sure that that opening is clean. And we'll see if it wants to start to go at least, you know. But hey, it looks pretty good. All right, the gentleman in the video, which I'll link to, said to use some silicone adhesive like this, which I have, and a syringe. But this is a 23 gauge. There's just no way to get this out without, it's impossible. He didn't mention what gauge needle he used, but it's probably a 19 or something. I don't have any, so what we're going to do here is we're going to use a coffee stirrer. The objective is not to put too much in, because if you put too much in, which we have to do is just around this this little shoulder here, it'll squeeze out when you put the lens in, and it'll kind of distort that. So we're just going to kind of go easy, and I'm going to spread some around by hand like this. I just can't seem to get that that syringe to cooperate. So we're going to do it this way. Naturally, I clean this real well. I clean this with the rubbing alcohol, and clean the lens with rubbing alcohol too. I don't want to use brake clean on the plastic because I was afraid it would screw up the plastic. Alright, looks like we got it all the way around. I'm going to use the C-clamp with some tape on it to push it in, but it is starting with some just by hand pressure. I'll see what it'll do just by that. Got to make sure my hands are clean here, much as possible. I don't want to let that glue set up any though. I want to get this in. So we got the little bevel, which is going to go out. The bigger bevel goes in. Let's see what happens, folks. Oh yeah, that's a nice fit. Now we'll squeeze it the rest of the way with this. Yeah, I got a little squish out on the top, a little bit on the bottom, but hey, you know what? He did too, so I'm not going to worry about it too much. That's okay. I know it's all the way around. I can actually see it almost all the way around too. Pretty much squishing out just slightly, so that's fine. But yeah, look at that. So we're in nice and straight, flush. That size worked out well. It was about not quite a half thou, according to those calipers, below the size of this hole. So that worked out well. So anyway, yeah. Now, keep in mind, folks, we're not going to know if it's 100% of a win until tomorrow. We're going to let this dry overnight. That's when we'll pick the video back up. But a couple points I wanted to make was that I'm not going to use this as a permanent repair. Eventually, I'm going to be taking both of these back off again, and I'm going to, paint them. I got to figure out what color paint that is for both the front brake master, as I said, and also the clutch master cylinder. And at that time, I'm going to get them on order and get some actual 18 millimeter proper windows, for these things, these sight glasses, for these master cylinders. Then we'll put that in. This is temporary. I looked online real quick. I couldn't get those for weeks. The other interesting thing is this. Is kind of interesting. The parts fish for this bike does not break these out. Usually they do. I've seen them many times on parts fishes where you see the sight glasses as a separate part that you can order. Not on this one. So if you were going to replace this, perhaps back in the day, you'd have to replace the entire master cylinder, or do it this way, or get the right aftermarket solution, which again I'm going to order. So yeah, I think it looks pretty good. Will it work? We'll find out. It'll be probably close to 24 hours for me, or maybe not 24, but 18 hours for me, and about 10 seconds for you. Hey folks, next day, and of course he's trying to sneak up to the road. But at least he's listening this morning. Gotta love dogs. Alright folks, we're back over at the dirty bench. I'm really sorry about this. My lathe does not normally look like this. I just haven't had a chance to clean it. I was cutting some brass the other day to make a bushing for one of the arms where it pivots on that anti-dive on the VFR side where a pin goes through. There's essentially a bushing was made out of plastic. I made it out of brass. It's much better. I just haven't had a chance to get to it. Plus all that plastic from yesterday. Yikes. But let's take a look. This is what I did. After the last clip where you saw me install this replacement sight glass, I rebuilt the master cylinder with the parts from Brake Crafters. And then I put this, just a regular banjo bolt with a brass spacer I'd made a while back for this kind of purpose, and then set it aside. Now, I did not put any fluid into it until this morning, maybe about an hour and a half ago. Came out here early and set it up like this, put the fluid in, and walked away. So we're going to take a look and see how we did. On the front here, looks good. There's no leaks, no drips, no nothing coming out of this sight glass, and I think that'll be fine. Now, as far as the material compatibility goes with brake fluid, I'm not 100% sure. I wouldn't think that they would have used anything other than like polycarbonate, like Lexan, whatever you want to call it, that material, to make that out of. I mean, that's pretty much a standard material for that, I would assume, but I guess we'll see. Remember, it's not permanent. It's going to be temporary until I put another one in, but it may not be for quite a while before I get to that. So it might be, let's call it semi-permanent. Okay, so that's pretty good. I'm liking it a lot. So what we're going to do now is I'm going to drain this out, get it installed. You're not going to see any of that. But the next clip you should see is I'm going to have everything back installed. This, the painted up calipers, everything rebuilt and functional, and I'll show you what they all look like because I think they're going to look pretty good. So stand by. Alright, here's the left side. This is the side that has the anti-dive. Inside here, this arm that comes out is where I made that bushing. This bolt goes through like a top hat washer that sits inside that bushing, and I just made a new one out of brass. Put it in with some sleeve retainer, and then so it won't thrust laterally because there is a little play in there. But yeah, we're ready to bleed now. I haven't done that yet. Let me show the other side. I think there's probably a lot of questions, and I don't know the exact answer to this, but this is how I do it. As far as bleeding in the order of operations, we're going to bleed the master cylinder first. I'll show you a little trick on that. But once you get down to calipers, when you have dual calipers, even something that's even more exotic, kind of like that GPZ 750 with the dual valves that have the anti-dive setup in there, I always do the left one first. And my rationale for that is it's closer to the master cylinder. And so I don't want to go to the further one and then have air in the closer side. I think it's going to skew things. So I start up top, go to the closest one, bleed that one, then go to the farthest one. If I need to, I'll come back to this one, but usually I do not. So anyway, let me show you a little trick about getting this set up. Whenever you crack a system, and in this case we were very well cracked and rebuilt everything, master cylinder, calipers, a whole bit. I want to bleed the master cylinder first. So right now I have fluid in it, and let me set you up in the stand and I'll show you how that's really quickly done. I got you on the other side so you can actually see the level of the master cylinder and also what I'm doing here. So I got a rag underneath here, as you can see, and what I'm going to do is I'm going to just work it. Let me see if that snugs up good. Yeah, I'm going to work the banjo and just bleed that through. So the first thing we're going to do is just open it, give it a squeeze, close, open, give it a squeeze, close, and what we're looking for, of course, is the fluid to come out, which kind of hard to see from my vantage point. Oh, there it goes. Do it one more time. Okay, so we got fluid coming out of there. Got to tighten that more. And so now we're good as far as the master cylinder goes. Because if you don't take the air out of that master cylinder up here, it's not going to bleed up. You're going to have a super hard time doing that. So now I'll get the rag out of the way. Tighten this clamp up a little bit more and really give this a good snugging, because these have to be tight, these banjo connectors. Don't be afraid to put a little bit of torque on those. I mean, they're 10 millimeter bolts, and I think it's a 1.0, so it's a fine thread pitch, pretty sure. Maybe a 125, I'm not sure. But anyway, you can crank on them, so don't be afraid to do that. So let me do that off camera, then we'll move down. I'm going to do the brake caliper bleeding off camera because it's kind of an anemic procedure. I just wanted to show you the master cylinder because sometimes that gets a little tricky. Okay, so I'm all bled up, and this was a little bit of a testy one. It was stubborn to get it to bleed out, to get the pressure down below. It just wouldn't flow real well. That's really atypical of a rebuild. When you get new parts in a master cylinder and it's all clean and reassembled correctly, which this one is, usually these things bleed up pretty quick. So if they don't bleed up pretty quick, I'll give you a couple of tips. First of all, I re-bled the master a couple more times the way I showed you, and make sure that there's no air in there. But I'm telling you right now, there probably is some air in there. Before I tell you these tricks, I need to show you something in here. I'm going to kind of bend the camera down and put it up in here. Now, when you look down the master cylinder, you see the main hole, and you also, let me see if I can zoom up on that a little bit. You see that there is a metal tang, like a little metal piece, that sits inside that hole. It's horseshoe shaped, and then it extends out a little bit higher, almost like the heel. Looks like the heel of a shoe. That is a little plate that prevents the brake fluid from coming squirting out when you first squeeze this lever. What that is the little relief port for when you apply the brakes under normal operation. They squeeze, they have to back off a little bit. So the pressure has to equalize or normalize again. And that pressure normalization happens at that hole. Unfortunately, a feature of the way these things are set up is the way this piston goes in, the piston is actually a little bit behind that hole. So when you first squeeze this a little bit, there's going to be some pressure generated, of course, but it's not all going down here. It'll start to come out that hole first. And as soon as you get past just a little bit more, that hole is closed off because remember, it's a relief hole for when this thing is fully extended. So it doesn't take much. And then what will happen is your pressure will go down the line and it won't squirt up. I'm only mentioning this because the procedure I'm going to suggest to you, if you don't have that little tang in there or cover this up somehow, it's going to get fluid everywhere. All right. The clutch master cylinder over there does not have that little tang in it, and I found that out the hard way when I flushed that. So when I go into that one someday to rebuild it, I keep those in stock. I'll snap one in. But anyway, so if you're having a hard time bleeding it up, the first thing that I do is I go, okay, if I can't get this one to bleed up, maybe I can get the other one. I know I said I started with the left, but it doesn't always work. At that point, I came up here and topped the reservoir off here, and then started flailing this thing. Boom, 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 boom. Just going at it all the way in, just over and over and over. And what that does, if you were able to look down into the master cylinder when you're doing that, you will actually see bubbles coming out of the cylinder here because it's just not completely purged of air. Most likely because of the angle here, but there's going to be a little air left in there. And this kind of rattles its cage, kind of, so to speak, and gets the air to move, and it comes out the master cylinder there. Sorry guys, I had to put the fan on. I mean, I'm sweating bullets. I'm sweating more than a Chevy guy at a Ford rally. What was I saying? Okay, so you flail this thing back and forth, and you get that air to bubble out, and you'd see it happening. Now, once that happens, you're all of a sudden you're going to start to get some pressure backwards, like you're starting to build up your pressure down here and moving those caliper pistons out where the pads are hitting the rotors. And once you get to that point, you're almost home. You got it almost done. Now at that point, what I do is I hook my drain up bleeder, whatever you want to call it, which in my case is a Gatorade bottle with a plastic hose. I also have a one-way check valve made in there out of an end of a glove, and so it doesn't really matter. But anyway, I hook that up, and then I build pressure and hold that pressure, and then crack the bleeder. Then this goes all the way in, and then I close the bleeder, and then I build it back up. So once you start getting pressure, I think the best way to do it is to build up pressure, then crack the bleeder, build up pressure again, and repeat the process on both sides. And that's exactly what I did on this one. There's also another trick sometimes that works, where if you can't get it to bleed up by pushing this lever all the way in, if you put like a, even in your mind if you want to do the spacing, but you put like a, 9/16 or 5/8 socket in here and push it up to that point. In other words, not going all the way in. Sometimes that works on some of the old Hondas. I don't know why, but sometimes it does. So I did try that too. I went only about 3/4 of the way. I still couldn't get it bled up. So I did it the way I just said, where I flailed on this thing, got some pressure built up, and you'll feel it when it starts to go. And then got it to build up, and then, like I said, did it that way. So, yeah, she's all bled up, and there's a couple of tricks to help you out. And before I put the top on, I wanted to show you that little tang in there that prevents that squirting up when you first hit this thing. By the way, if you're interested in what fluid I use this Valvoline Synthetic .3 and 4. These generally take .4. Some of the older stuff says .3, so this works on both of them, both systems. The only difference between .3, 4, and that new 5.1 or whatever it's called is temperature. They're rated for different temperatures. So they have a little bit of different chemical formulation, but for the most part, they're the same. So if you had a .4 and you only had .3 fluid and you had to get it back in service, you most certainly could use that. But my recommendation is always go with what the OEM suggests. So in this case, since it's .4, we've got .4 compatible or .4 rated brake fluid. Okay, so we're all buttoned up. And there's your master cylinder with the new sight glass. As a comparison, if you want to take a look at that one over there, there's the one for the clutch master cylinder, which I'm sure is not long for this world either. And yeah, it came out pretty good. I got everything buttoned up here. The signal's back on. The stays for the brake lines, which also hold the fender in. Everything's tight down here, wiped down, and everything else is torqued up. All we really need to do is take it for a shake and burn these things in a little bit, wear them in. do some hard braking up and down the road a little bit to kind of seat them. But we're not going to do that today, most likely. Number one, it's too hot, and number two, I've got to do a ginormous amount of cleanup, both here and over at that lathe. Ugh, this place is an absolute pigsty. So, not normally that way, but sometimes it gets that way when you got 18 things going on at once. I'm not going to include any more brake stuff because this video will get too long, but someday I'll have to do some more detailed brake work on these calipers and show you a couple tricks in regards to that. I will tell you where I get my kits from, in case you're wondering. I get my kits from a place called Brake Crafters. They're in Ohio now. Brake Crafters sells excellent stuff. They come in a kit that looks like this, all individually packaged as far as the kits go. So nice little segments there, or little sections that they put stuff in. And generally in a kit you get the packing, the rubber seals, and you get the new bleed valve, the new cap, and of course your new banjo seals, and whatever else is typical for that particular application, and a couple of neat stickers. I will say one thing though, I'll have to show you another video how you can reuse these banjo washers if you've got a leak in one and you just don't have any more in stock. I'll just do that separately, but remember these are copper, and so you can do a little bit of a heating and cooling trick on these, and then cleaning them up with a little sandpapering, go back in, and they essentially annealing them, because once these things are put in, you torque them up. Copper work hardens just like brass does, and so these things are not going to collapse or conform under the torque of what this bolt is rendering when they're already used, or at least not as well. We'll have to go over that. The other thing is, I really needed to order new ones of these banjo bolts because these look like crap. Someday I'll do that, but these guys here I completely forgot about. These are these little caps that go over top of the hex pins. There's like a hex threaded pin that goes through to hold the pads in place. And these are just kind of caps that not only protect them, but it acts as a locking backup. And these were really hard to take out. They usually are. And they usually get tore up. And two of these, one on one side, one on the other, was already pretty mangled. So I'll get new ones of those because I'm pretty sure I can get those OEM. We'll put it back together in the future time. Just do it right. Anytime we can do that, just unscrew and put new ones in. Lastly, the paint that I use on calipers like this, and I did the same on the rear, is actually wheel paint. Like that duplicolor rim and wheel paint. I guess you could use caliper paint too, but I like that wheel paint. It's somewhat resistant to chemicals, but like regular Rust-Oleum I wouldn't use, because as soon as any brake fluid hits it, even if it's been cured for a while, it's going to start eating it away. This stuff works pretty well, and I just sprayed them yesterday. So I have barely 24 hours on these things as far as the paint goes. That's what I like to use. It works pretty well, in case anybody's wondering. Okay, so here we are, back where we started with the sight glass on the master cylinder for the front brakes on the VFR 750. This is a really good example of the don't just repair, restore that I say at the end of every video, because we definitely restored this one. Now, yes, you need some machine tools for this, but even if you had a little cheapo mini lathe and a drill press, you could easily do this yourself, or just order them and then put a new one in, that way. But you already know the reason why I did it this way, so no reason to beat that dead horse. So I just want to say thanks for watching, everybody. Today is Father's Day, so the 19th of June, so happy Father's Day to all the fathers out there. I'm going to clean up, and then I'm going to take the rest of the day off because it's hot, and once I get this mess picked up, I'm done. And this video's done. As always, don't just repair, restore. Thanks for watching. Catch you on the next video. That's a lot better. Have a great rest of your day, guys.